Question 7b, it says the equations x squared plus ax plus b equals 0 and x squared plus bx plus a equal to 0 both have real and equal roots, and we want to solve for a and b. So because they have equal roots, you can set your discriminant delta to be equal to 0 for both of them. So for the first one, my a value is 1, that's the coefficient of x squared. My b value is a, which is the coefficient of x, and my c value is my constant, which is b. So delta, which is b squared minus 4ac, will become b is equal to a, so it will be a squared minus 4 into a, which is 1, and your c value is b, that must equal to 0. And if I clean this up, you're going to get a squared minus 4b is equal to 0, and I'm going to call this equation number 1. And then similarly, for the second quadratic, again we're going to set delta to be equal to 0 since the roots are equal. Here a is also equal to 1. Here b is equal to b, and c is equal to a. And so my discriminant becomes b squared minus 4 into a into c, which is a, is also equal to 0. So this becomes b squared minus 4a is equal to 0. And this will become equation number 2. So now we need to solve for equations 1 and 2 simultaneously. We can make b the subject of the formula in equation 1. So that's going to give me b is equal to a quarter a squared. And I can substitute this value for b into equation 2. So now this will give me b, which is a quarter a squared all squared minus 4a is equal to 0. If I square the bracket, I'm going to get 1 over 16 a to the power 4 minus 4a is equal to 0. And if I take out a as a common factor, we're going to get a into 1 over 16 a cubed minus 4 is equal to 0. So your two solutions are a is equal to 0 or a cubed is equal to 4 times 16, which is 64. And if I cube root 64, I'm going to get the a value to be 4. And so to get the value for b, we simply substitute a equal to 4 back in equation 1 or 2, or even here we can put it b is equal to a quarter multiplied by a squared, which is 4 squared. So 4 squared is 16. A quarter of 16 is also 4. So the values for a and b are both 4 and 4.